Hello, my name is Randall Edick from Structures Office, and in this video we're going to walk through the material database that's shared among the various Structures Office applications. Let's walk through some of the definitions to begin with. FTU, and you'll see FTU underscore L and underscore LT. FTU is the ultimate tensile strength, and the L stands for longitudinal, and the LT stands for longitudinal traverse. And this is the value that's used most in section margin of safety calculations. As of right now, we're only using the longitudinal values in compact sections 2.0, thin wall sections 1.0. That's going to change in the future. FTY and FTY-LT. FTY is the tensile yields, and this value is the not to be exceeded for limit loads. FCY is compressive yield strengths. However, the critical compressive stress is a function of other factors such as buckling and crippling. FSU is the ultimate shear strength, and this is the value that's used in the shear margin of safety or in interactive tensile and shear interaction margin of safety calculations. FBRU and FBRY is the ultimate and yield bearing strengths, respectively. These values are used for checking the material and bearings, such as a fastener bearing against the fastener hole. The selection of these values also depend on what is called the E over D edge distance ratio, which is the hole center to edge margin, E, over the bolt hole diameter, D. And finally, the total strain percent at ultimate failure, the test coupon, typically used to evaluate how much compliance the material has before failure. Ramberg-Osgood equation. There's a number of plotters out there. This image is taken from p/a.co.uk. So here's the equation, the Ramberg-Osgood equation. I'm going to take just a minute and explain how this thing works. So you strain. Well, you have Young's modulus, you have the 2% yield stress, you have your curvature parameter, M, and that's what this equation uses. You can think of this portion, the stress over Young's modulus, as the linear part of the curve. That's this part. You can see when the stress is less than your 2% yield stress, and you have this exponent, which is usually pretty large, that value is effectively 0 if it's less than T, if sigma is less than T2. So it has almost no effect until it gets up to the point where it's close to the yield stress, and then this starts having an impact. When it equals this yield stress, this value is going to be 1. So then you're right at the 2%, right here. In the database, you're going to see two sets of these values, the curvature parameter and your percent yield. That's for initial up to the yield, 2% yield, and then there's another set of parameters, the curvature parameter, to go and model this part of the curve. If you don't have the material specs, you can get them from the Metallic Materials Property Development and Standardization document, the MMPDS. The controls for the material database are found underneath the Materials tab, and this is shared among all the Structures Office applications. You see there's functions to control the database connection, edit the materials, and apply the materials to branches of the section. If you click on Show Path to the Database, you'll see which database this document is using. By default, it uses the Users Public Documents Structures Office, structuresoffice.sqldb, that's created during the installation. There's also functions to create a new database, and it will put in the default materials or change the connection to a different database. If you click on Edit Materials, you see what materials are defined. in this database. And there's functions on the right here to add, edit, delete, unselect just unselects the item in the list, view, or create similar. If you click on a material, you'll see these functions activate. Edit, you'll get this error message that says the database is the sole authority for material definitions. Editing a material will affect all objects using that material in all Structures Office documents. Are you sure you want to continue? What that means is that values are not stored for the material properties in the documents itself. It always pulls it from the database. If you change a material that other documents are using, the next time that document's open, it will pull in those new values. Clicking yes shows you what the values in the database are. And now I'm going to walk through them and just explain because it looks a little complicated. Here's the description. It has the name, the spec, the family, and the Unified Numbering System ID. Here's a function to switch between the USCS and SI unit systems. And you'll see that each of these materials has a unit system. And that unit system has got to match whichever unit system the document's using. So you can switch back and forth between these two. Here's your Young's modulus for tension and compression, shear modulus, Poisson's ratio, density. The yield allowables for compression and tension. And you'll see you get longitudinal and longitudinal traverse. If you're not using longitudinal traverse, you don't have to enter these values. But you would have to enter your the longitudinal values, the compressive, tension, yield, and then your ultimates for tension, compression, and shear. Over here is a Romberg-Osgood equation that we just talked about. And you see it has values from initial to yield, and then from yield to ultimate. And that's for tension and compression, longitudinal and longitudinal traverse. Here's your curvature parameter in the percent yield offset. So if you're using the same equation throughout, you'd use the same values here. You'd have the same M value. In this case, they're different. But you have to enter a value from yield to ultimate, even if it's the same. Down here's your max strains, tensile strain and compressive strain. As you know, that compressive strain is going to be a factor of other things such as crippling and buckling and when you do a computation. Bearing allowables. This is the E over D ratio, the 1.5 and 2.0. And that's yield here, ultimate here. And down here is an option to lock the material. Locking the material means nobody can edit that material again. That's just a warning that says your Poisson's ratio doesn't exactly match the E over 2G minus 1. So if we were to create a similar material, and we have to give it a name, and we edit it, and if I go and I turn on lock this material, you see you're no longer able to edit or delete it. Up here is, if you had a large number of materials, you can control searches for, say you want a family and you only want to see families that start with AL%. So that's just a filter. But for these small number of materials, you don't need it. So each branch can have its own material, and you apply materials with these functions here. You can apply it to all, and you select what material you want to apply. And it applies to all the branches in the section. If you want to apply to a single, and there's also functions to apply by right-clicking, and it gives you the same function. Database administration. The material database is stored in a single file, and it can be managed like any other file. It can be copied, renamed, deleted. And it's the administrator's task to back up the material database, which means copying that file to some safe location. The database is using SQLite and can be managed with SQLite browser as well. You can get that browser from SourceForge.net project SQLite browser. So here is the SQLite browser. They have tabs for the database to see the database structure, or to browse, and there's only two tables that relate to non-material database. One for controls, which controls the locks, and the other is the material properties definition. All your E's and G's and the various allowables. So you can go in and you can delete records, change values, execute SQL. Same as any other database. So that concludes the presentation on the material database.